here we're told determine a recursive formula for the sequence below. So here we have 1, 15, 53, 127, 249, comma, dot, dot, dot. So just by inspection, it's kind of difficult to see what the relationship is between the preceding term to get the nth term. So one of the things that we can look at is we can look at the differences between terms. So 15 minus 1 is 14. 53 minus 15 is 38. And 127 minus 53 is 74. $249 minus 127 is 122. Okay, so between the differences between terms, it's still hard to find a pattern between the differences between terms. So let's see if there's some kind of pattern in relation to the term number in terms of the differences. So what I mean by that is, let's see if there's, let's write out a table of values. And let's write out the term number, and let's figure out what we added to the previous term in order to get the nth term. So let's call d the difference that we added to the previous term to get the nth term. To get the second term, we added 14. To get the third term, we added 38. To get the fourth term, we added 74. And to get the fifth term, we added 122. So off the top of my head, I still don't see a pattern here. So since we have a table of values built, let's go ahead and we'll try to calculate the finite differences and just see if there's a pattern in the finite differences. So 38 minus 14 is 14. 74 minus 38 is 36. And 122 minus 74 is 48. So now we see that in the first differences of the differences between terms, the first differences are increasing by 12 each time. So that means that the second differences are going to be constant. So here we have that that we're adding 12 to the differences, or adding 12 to the first differences of the differences each time. So what does that mean? Well, it means that these differences have a quadratic dependence on n. So that means that like 14 or the nth term, the amount that we're adding to the previous term, is going to have a quadratic dependence on the value of n. So let's go ahead and we'll see if we can come up with that, with what that quadratic formula is in terms of n. So right now, what I mean by this is that if we have the nth term t sub n, it's going to be the nth term is going to be equal to t sub n plus some quadratic dependence on n. So we have t sub n is going to be equal to t sub n minus 1 plus an squared plus bn plus c. And I know that because the differences have a quadratic dependence on n. That's what we've shown from this table of values. So now the game here is to figure out what a, b, and c are. Now, if you recall from previous lessons, we know that that 2a is just going to be equal to the second differences. So we've got that 2a is equal to 12 here. So a is equal to 6. Now we can figure out what else we know. We know that when n is equal to 2, we're adding 14. So we have that when n is equal to 2, and let me just get rid of that dot here. It looks like I've rounded there. When n is equal to 2, d is equal to 14. So the amount that I've added to the previous term is equal to 14. And so I have that 14, I can kind of build an equation out of this. I've got that 14 is equal to 6 times n squared, which is 2. So 6 times 2 squared. Plus 2 times b plus c. We can call this equation 1. And we'll build another equation. We know that when the term number is 3, we're going to add 38 to the previous term. So we've got that 38 is equal to 6 times 3 squared plus 3b plus c. And now I can go ahead and I can subtract equation 2 minus equation 1 is going to give me, let's see, 38 minus 14 is 24. 6 times 9 is 54. 54 minus 24 is going to be 30. And then I have 3b minus 2b is going to be b. C minus c is going to be 0. So we have that b is equal to minus 6. And lastly, we can substitute b being negative 6 into either of these equations. So we're going to sub b is equal to minus 6 into 1. And if we do that, we get that 14 is equal to 6 times 2 squared is 24. Plus 2 times negative 6 plus c. So we've got an equation now that we can solve for c because it's one equation, one unknown. So we've got 24 plus negative 12. 24 plus negative 12 is just 12. And so 14 minus 12 is 2. So we've got that c is equal to 2. So therefore, the recursive formula is, let's see here, t sub n is equal to t sub n minus 1 plus this quadratic expression that we came up with that depends on n. So this would be 6n squared minus 6n plus 2. Now this problem is kind of challenging, and we want to make sure that we have not made any kind of errors, like there's no flaw in our logic, but also that we haven't made any arithmetic errors along the way. So let's, and here we have to state what the first term is. So t sub 1 is equal to, what was it? It was just 1. So let's go ahead and we can and see if we can calculate the second term in terms of the first term, just as a kind of way to verify that what we've done is correct. So we've got that t sub 2 would be equal to t sub 1 plus 6 times 2 squared minus 6 times 2 plus 1. T sub 1 was 1, so I've got that, plus 2. I made an error here. So minus 6 times 2 plus 2. Made a mistake copying that equation down. So I've got 1 plus 6 times 4 is 24, minus 12 plus 2. And here we've got 12 plus 3 is 15. So t sub 2 is equal to 15, which matches the sequence that we had above. And let's make sure that t sub 3 is correct as well. So t sub 3 was equal to t sub 2 plus 6 times 3 minus 6 times 3 squared minus 6 times 3 plus 2. And t sub 2 is 15. So we've got 15 plus 6 times 9. 6 times 9 is 54. minus 18 plus 2. 15 minus 18 is negative 3. Negative 3 plus 2 is minus 1, so it'll just be 54 minus 1, which is 53. And we've seen that this matches our third term. If we go ahead and we calculated the fourth term and the fifth term, we would see that they are correct as well. So you can do this for the second term, the third term, and the fourth and the fifth term, but what we have is correct, and I leave that to you as an exercise.